Hi y'all, this is the first of what should be many different videos, all talking about mathematics. In order for us to do this, though, we should probably have a little conversation about how these videos work, what they do, and why I'm doing it in the first place. My goal in this videos is to give you a resource that will talk about math the way that we'll be talking about it in class, and just kind of my thoughts and concepts on some of these problems. There are many, many, many other resources out there, and you should not think that my videos or my teaching is the ultimate resource. In fact, the more resources you use, the better off you'll be. And when those resources argue with each other and they get confused, and then you get confused, it'll give us great discussion in class. So that's pretty awesome, and that's a good thing, not a bad thing. Now, as you can see on the screen right now, there are several different things that are going to happen in my videos. Number one, there's going to be bad handwriting. It's just going to happen. It's just the way it is. It's just how it's going to be. I'm writing on a tablet, and I don't know if you've seen these tablets, but anyway, just that's the way it is. Number two, there's going to be bad jokes. I'll save one for later. I wouldn't want to start with one right away. So there'll be these two. Yup. Now, these videos are not designed to just be watched and just used as, you staring at the screen and me just keep on talking. We could have done that in class. The goal of these videos is so that you can stop the videos when you need to. You can write down what I'm doing. If you just watch me, for example, solve this problem over here, you're not going to get anything out of it. The next thing you're expected to do is think, I can't do that for you. No one can do that for you. That's the one thing you can truly do. Then you come back in, you watch, you try the problems, you do them. These are going to happen in a lot of different orders. Sometimes you'll write, then stop, then think, then stop, then watch, then stop, then do. Sometimes you'll do and watch at the same time while you think about writing. Okay? So I'm going to come over here and we're going to solve a couple of problems. And as we're doing this, problems like this at the very beginning I'm doing because I want us to talk about the process of problem solving as opposed to just solving a problem. See what I did there? Yeah, that's clever. I know. I know. So let's look at this problem over here. We've got 2x plus 6 equals 17. Now, in this class, you should know how to solve this already. So what I want you to do is, in a second, I'm going to ask you to pause the video. I'm going to ask you to try the problem. I'm going to ask you to get an answer. And then come back and watch the rest of the video. And then we're going to see whether or not yours matches mine. All right? Ready? Pause. You paused it, right? You paused it and you did it? You're hearing me now after you've paused it and done it, right? You wouldn't dare just watch the video and not pause and do the problem, would you? No, you wouldn't do that. Okay, so let's try this problem together. The first step I'm going to write is 2x equals 11. Now notice I did not write the middle step here. I didn't write subtracting 6 from both sides. There is a step here. Yes, there's a step here. And notice that I described it in words as subtracting the 6. There will be times where we go through problems like this where I will mention what happens in a step and not write it down. This is important to you because if you don't know this step, you need to make sure that you write down that I said subtract 6. Let's now do our next step. I'm going to write x equals 11 halves. And what happened there is I divided both sides by 2 to isolate x by itself. Now many of you may have written down other answers. You may have written down x equals 5.5. You may have written down x equals 5.5. Now this answer right here, I do not like. This is a sad face. Okay? This one, 5.5, is okay, but we're just going to stop at improper fractions. Improper fractions are great. We'll talk more about that in class, but just leave it as 11 halves. Don't worry about this either. This one, I do not like mixed numbers. We'll talk about why, but they just confuse us and make us sad people. 11 halves is awesome. Great job. So we've just solved our first problem together, and notice that when you watch it with me, you actually find out little pieces of information that I care about, like 11 halves. So let's flip the page here, and let's look at a problem that you may not be comfortable with. Alright, so here's a problem you may not be comfortable with. This says sine squared theta plus cosine squared theta equals 1. This is awesome. It's a derivation from the Pythagorean theorem. It does all kinds of cool things. But what I want you to do is I want you to try to isolate sine squared theta and then factor the other side. So pause the video. Try that right now. Cool. So you pause the video, you tried it, and there may be things that you are not comfortable with at this point, which is totally fine. We're going to walk through it together, but the important thing is you tried it first. So when I say isolate, that means I want to get sine squared theta by itself. In order to do that, I'm going to subtract the cosine theta. So I get sine squared theta equals 1 minus cosine squared theta. Okay? Now, again, I didn't write this step down, and this is something you are less comfortable with. So make sure that you understand to isolate. You make sure that you understand these pieces that are happening. Now, the next thing I said is I wanted to factor the other side. So I'm going to do that now, and I'm going to use my factoring rule of a squared minus b squared. And so I get sine squared theta equals 1 minus cosine theta and 1 plus cosine theta. Now, up here, I mentioned a rule that I was using, which was a squared minus b squared equals a minus b, a plus b. This is a rule you should have gotten in Algebra 1. I normally will not write this down. I'm writing it down right now to prove a point, and to prove a point that I mentioned this rule. And if you didn't know it, you might not be able to go from this step to this step. That's your time for you to say, hey, I should look that rule up. I should make sure I know it. It's clear he's expecting me to know it, so I need to make sure that I can do this. In order to make this happen, it must be clear that you are allowed to go back to the future. You are allowed to rewind. Watch that piece where I talked about it over and over and over again. That way I don't have to repeat it for everyone. I just repeat it for those of you who need it. You can do this in the privacy of your home. It's awesome. All right? So I used that to get here, and I've done everything I need to. I have isolated sine squared, and I factored this side. Everything went great. Awesome. So now we're going to move to the last piece of my videos. And usually what I'm going to do is I'm going to have these at the very end, and I'm going to have 2 problems for you to do. How this is going to work is I will put up the problems. I will then show the answers. I will then do the problems. Now I get to do this because editing is pretty awesome. But what's going to happen is you're going to pause it, you're going to do the problems, and then the answers will appear. And if you had any issues with doing the problems or you have any questions on the work, you can then go through and watch the last piece of the video where I show some tricks and tips and do all those other kinds of things. So ready? Pause and do them. As you can see, our answers are 7 and 19/15. So if you had any problems or you did not know what I did or you want to know what this part down here is, then you should watch the rest of the video and you should watch and say, oh, I understand this, I get this. If not, you can pause here and say, I got these 2 answers right, I'm good to go. Alright, so now you're in the section of the video where I get to show you the answers. Now in this first one, there's not going to be a whole lot of work, and I'm just going to put down a 7. And you know what? I'll do it in a different color so that they show up brighter and happier. Boom, 2 plus 5 equals 7. Awesome, we're done. Over here, it's fractions. Ooh, let's add fractions. Now, I could find a common factor, and I could do all of that. But I'm going to use the rule that A over B plus C over D equals AD plus BC over BD. This rule is awesome for adding fractions. It's what we do all the time. It's just we never really showed you this. I don't know why. So hopefully one of your teachers at some point did. We're going to do 5 times 2, which is 10. We're going to do 3 times 3, which is 9. And we're going to do 3 times 5, which is 15. I now get 19/15. And if you remember what I said earlier in the video, I like improper fractions. I'll check to see if I can simplify it, but 19's prime, so that's not going to happen. And this is going to be my answer, 19/15. Just like this is my answer, which is 7. I probably shouldn't use brackets like this because they're not in a matrix, but that's fine. So here we go, 7, 19/15. Those are your answers. Thanks for watching, y'all. Have a great day.